Turning off the screen. There we go. So unit 6 is all about roots, square roots, cube roots, fourth roots, which hopefully you remember, okay, something squared, a number times itself. The inverse of that, a square root, is asking, okay, what times itself gives me that number? Square roots and squares kind of cancel each other out. They're inverses. Let's do some real fast review here. The square root of 0 is just 0. There's nothing strange with that one. I can take the square root of 0 and I will get 0 out. Come on. There it goes. So the square root of 0 is 0. The weird one that you've learned in the past, but that we're going to use a bunch here, the square root of -1. There is no single number that multiplied by itself gives us -1, because two negatives multiplied together always make a positive. So our little conceit, the way we make this work is we say, okay, the square root of -1 is going to be I for imaginary. Anytime you've got the square root of a negative number, we're going to put that I in there to hold its place essentially, and then do the rest of it like normal. Number 3, the square root of 32. This is what you've probably done the most with. If I take the square root of 32, I can take that 32, break it apart. 32 would be, we could do 2 times 16, which would be 2 times 8, 2 times 4, 2 times 2. So I'm breaking that 32 up into its multiples, essentially saying, okay, what multiplies to make 32, breaking each of those pieces down until I have, looks like 1, 2, 3, 4, 5 2s. 2 times 2 times 2 times 2 times 2 makes 32. So I'm going through here and I'm finding all of the pairs of numbers. So I have a pair of 2s, another pair of 2s. Square roots, look for those pairs. What times itself makes that? Take that out. So I have 1 2 that comes out, a second set of 2s that come out, and I'm left with a single 2 that didn't have a pair. So it stays inside. Square root of 2. This reduces all the way down to 4, 2 times 2. Any numbers that come out, anything that comes out in front is multiplied together. 4 times the square root of 2. That's my answer. That's the way we've kind of been practicing these. There is another way as well that you may have learned in the past. You can break that 32 up into a square root that you know the square root of. You could say that 32 is the square root of 2 times the square root of 16, because 2 times 16 makes 32. The square root of 16 is 4. That's my answer, 4 root 2. Does that make sense to everybody? It's the same thing, works both ways. You just need some way of reducing these square roots. Now, how many of you have done square roots of decimals before? You remember doing that at some point? Or is this new for a lot of you? Okay, new for most of us. It's actually really easy, okay? Take the square root of 4, just the number without the decimal. What's the square root of 4, everybody? 2. Then take the number of decimal places, 1, 2 decimal places, cut it in half. Half of 2 is 1. My answer should have 1 decimal place, 0.2. The reason that works is because when I do 0.2 times 0.2, 2 times 2 is the 4 that I want. 1 decimal place from the first one, 1 decimal place for the second one, I get my 2 decimal places back that I wanted. So as long as there's an even number of decimal places, just cut it in half, take the square root like normal, with the new number of decimal places, that's half of what you started with. All right, I want you guys to try a couple of these. Go to the homework and try number 2 right now. 1 and 2. 1 and 2 should be super quick. Go ahead and try numbers 1 and 2. Give you a minute. long as it's a nice one, the one that probably there won't do is this guy here. But it's a decimal, and I don't want decimal. I want the exact answer, which is why we did that whole factor tree and worked all of that. Yeah, well, I don't like improper answers or answers that aren't exact. Yeah. I would say I want actual answer. 5.7. One 32, 5.7, something that goes on forever. I don't want you to have to write out an infinite number of decimals. Just we'll practice the square root. All right. But let me know. Let me know if you have questions about how that works. But I'll tell you right now that on the test, I'm going to tell you I want exact answers. You won't get credited as a decimal when it's not. Almost. Wait a second. We'll talk about that in a minute. All right, let's go over those. And switch this back. So looking at numbers 1 and 2, just real quick here. Oh, I could call on somebody, but let's just go ahead and just chorus response. What's the answer for number 1? 5. Hopefully everybody's good there. Square root of 25 is 5. How about number 2? This one I'll take a volunteer for. What's the, go ahead. 0.3 is correct. Is everybody good there? Square root of 9 is 3. 1 decimal place because it had 2 to begin with. 0.3 is our correct answer. So now let's talk about cube roots. That is not the one we want. Get this class's notes. There we go. So let's talk about cube roots. Cube roots work exactly the same way as square roots, except they look for sets of 3 instead of sets of 2. So the cube root of 8, I'm looking for sets of 3. 8, I can factor out. Use the factor tree if you need to. 8 is 2 times 2 times 2. Is everybody clear that you could get that with the factor tree? I'm just not writing it all the way out because you'll hopefully start to recognize some of these cubes. So 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. 64 is 4 times 4 times 4. You'll start to recognize them because there's only going to be 4 or 5 that show up over and over and over again. Because anything bigger than like 5 cubed, we start to get into numbers that are too big to work with easily. So you'll see this cube root of 8 come up a lot. Cube root of 8, 2 times 2 times 2 is just 2. There's my answer. Right? Because I'm looking for sets of 3. There's 3 2s. That's 1 set. I get an answer of 2. Number 6. This one has a negative. For square roots, we said we had imaginary answers. We do not have imaginary answers for cube roots because 64, okay, I could do the factor tree. I could break it all the way apart. I could get 6 2s, or I could say that it's 4 times 4 times 4. That would be the faster way. It doesn't matter whether you do 6 2s or 3 4s. 4 times 4 times 4 makes 64. What if I make them all negative? Negative 4 times negative 4 times negative 4. 2 negatives, negative times a negative, negative 4 times negative 4 makes positive 16, times another negative does make negative 64. This is negative 4 3 times. So that's my answer. Negatives inside cube roots just give negative answers. In some ways, they're easier than square roots. I don't have to worry about imaginary numbers or anything like that. I just have a negative answer. And fractions. Fractions are actually not that hard with roots. You just take the root of the top and the root of the bottom separately. So the cube root of 1. Well, the cube root of 1 is 1 times 1 times 1. So the cube root of 1 is just 1 on the top. The cube root of 125. 125 is 5 times 5 times 5. That one works out real nicely. Cube root of the top, cube root of the bottom. Whatever you get there is your answer. For number 8, the cube root of negative 1 over 27. The negative comes out. Cube root of 1 on the top is 1. 27 is 3 times 3 times 3. There's my answer. let's say you get to the test and you want to speed yourself up a little bit and you don't recognize some of those cubes easily, grab your calculator and at the very beginning, write out the first few cubes. So 1 times 1 times 1. 1 cubed is 1. 2 cubed, just grab a calculator. 2 times 2 times 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4 is 64. And 5 cubed, 5 times 5 times 5 is 125. Those are going to be the most common things that have nice cube roots that we're going to use. So if you just want to write them down at the beginning, that might help speed your work up. Now, what if you're solving? If I want to solve x squared equals 81, I can take the square root of both sides. Square root, square root. X is equal to 9. That is not my only answer, though. There's a second piece to it. Anybody know what the second piece is? I have half my answer. There's another one that works too. So the square root of 81 is 9. -9 is the other one. The reason we have plus or minus, did you say it? Yeah. Okay, you just gotta be a little bit louder so I hear it. So plus or minus 9. The reason we need that is because if I put -9 in, -9 squared, -9 times -9 makes 81. Does that make sense to everybody? 2 negatives still make the positive 81 that I need. So I do need both of those. Those are both answers that work for this. However, for cube roots, I can get rid of the cube with a cube root. But this one, we saw that negatives inside a cube root stay negative. And likewise, if I do a negative number times a negative number times a negative number, I end up with a negative still. I don't need a plus or minus if this is an odd root, okay? Odd roots don't need plus or minus. Your answer is literally just whatever the cube root of 64 is, in this case, 4, right? We already said 4 cubed makes 64. Cube root of 64 would be 4. So cube roots never get the plus or minus. The actual rule here is if it's an even root, 2s, 4s, 6s, those can get a plus or minus. Odd roots don't. They're either a positive answer or a negative answer, not both. So letter C, x squared, take the square root of both sides. X is equal to plus or minus. Square root of 25 would be 0.5, because the square root of 25 is 5. 2 decimal places, our answer has 1 decimal place. Whereas for letter D, this one, cube root, get x is equal to cube root of -8. My answer is just going to be negative because I started with a negative. Cube root of 8 is 2. Now, we're going to backtrack a little bit because I skipped an example that I wanted you guys to do. We're going to do some ones like numbers 5, 6, 7, and 8 right now. I want you to do numbers 4, 5, and 6 on the homework right now. I'm going to do numbers 4, 5, and 6. Give you just a couple minutes to do those. 4, 5, and 6 on the homework. Bring a cube root for each of them. Yes. 121. Yeah, it's good. You'll see it all the way along here. Apparently, like a skip or something, spread out. All over there. Some of you are blowing all the way through. Just a warning, any of you that are working ahead, you may need to go back and add something to your answers because there's a new thing that we haven't talked about yet. But yeah, you're welcome to work ahead if you would like to. So let's go over these. Numbers 4, 5, and 6. Again, a lot of you are already done with those or you're almost done. Let's talk about number 4, cube root of 27. Emily Bolch is not here today. Nathan S. So what did you get for number 4? That's perfect. Cube root of 27 is 3. Number 5, Ethan Bravo, what did you get for number 5? -2 is perfect. And then number 6, we got this fraction, 2 pieces. Julian, what did you get for number 6? 4 over 5. There we go. Does that make sense to everybody? So now let's go back and take a look at the next section. Here, a lot of that was review, not everything, but a lot of it. We have a little issue though. We're not going to be solving today. We're going to be just simplifying for the most part. The issue is related to that plus or minus piece. If I have a squared inside a square root, like right here, this example in your notes, what's the square root of 81? 9. The square root of x squared would just be x. But wait a moment. What if I plugged in a number? If I plug in 5, 5 squared is 25. I take the square root of 25. I get 5 back. We're all good. But what if I start with a -25? -5. -5 squared would be +25. Does that make sense to everybody? I take the square root of 25 and I get 5. My negative has disappeared. It's gone. Does everybody see that? That with the original one, any negatives that I put in here will disappear. I need to make sure that my answer reflects that. Any negative that I put in here is gone. I need the same thing to happen down here. The way we do that is by putting absolute values around that x to show that if I put a negative in, it still needs to become positive. If there's going to be anything that's going to be tricky for you today, it's going to be that. Okay? I'm going to show you as many examples as I can. I'm going to answer as many questions as I can. If you're not sure, should it have absolute values or not, raise your hand and let me know. But here is the most direct, simple way I can explain it. If you start with an even exponent, right? That 2 is even. And you end with an odd exponent. So there's a 1 there essentially. You're probably going to need to put absolute values around it if this was a even root. So square roots, 4th roots, 6th roots, those might need absolute values. Cube roots are actually easier. No absolute values ever. You put negatives in, you get negatives out. Does that make sense to everybody? Hang in there. So here we go. Letter B. Now, I could write out 12 A's, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I could find pairs of A's. 1, 2, 3, 4, 5, 6. A to the 6th power. Anybody know a shortcut? Anybody have an idea of how we could do this simpler? Yeah, divide by 2. Does that make sense to everybody? If I'm looking for pairs of 2, sets of 2, I can just divide however many I have by 2. So if that's the case, how many sets of B's can I take out of that square root? Yep. Which of those needs an absolute value? the B's. Because I go from an even set in here to an odd number outside. And again, the reason we're doing that is negatives. If I have two negatives, they cancel out. Pairs of negatives cancel. The A's, I have pairs in A to the 12th. 2, 4, 6, 8, 10, 12. That's all paired. A to the 6, 2, 4, 6. Those are all pairs. All the negatives cancel out in both of those cases. For the B's in the first one, B to the 10th, 2, 4, 6, 8, 10. All those paired negatives cancel out. But B to the 5th has an extra negative that doesn't get canceled out. In order to make it match, I put those absolute values around. And really, the rule you can use is just if I go from an even exponent to an odd exponent, I need absolute values. Does that make sense? So now, let's go ahead and try numbers 10 and 11 in the homework. Here, there's just a square root of 25. And again, you can always try it on a calculator. If it works for the whole number, that is the right answer. Then, take the square root of x squared, the number, the variable. And we send our shortcut was divide that by 2. So here, 2 divided by 2 is 1. We're going to have 1x that comes out. Except we go from a 2 to a 1, so just on the x, not on the 5. The 5 is already positive. I'm not going to worry about that. We're only putting the absolute values where they calculate. Okay, with the 3 on the inside, okay, the 3rd goes around the whole, and that was the 3rd. That one I would give you credit if you put it just on A to get the same. So here's your outline. If you want that little chart over there, when are we ever gonna have to use this? Shows all the different careers, like on the top. But it's like 50 different careers and showing you where the different pieces go. So you might not use this, but probably use something to go over. Just depending on what you end up doing. Yes. Your original one. So even if it, we'll talk about that in a minute, right? Because the trick is there, you're going to leave some B's back inside the square root still. And so that's its own kind of thing. It'll still, the big thing is to make sure your answer matches with what you originally put. All right. So real quick there, number 10. Let's see what we got. Alyssa, what'd you get for number 10? 5 absolute value of x is perfect. And then number 11. Julian, what'd you get for number 11?
8, 3, 6.
Yep. Absolute value of a to the 3rd times b to the 6th. Is everybody okay there? All right, so back to our notes now. Letter C. Here we've got variables and numbers. Other than that, it's the same thing we've been doing. The square root of 36 is going to be 6. X to the 12th, I can just do 12 divided by 2 is 6. Y to the 14th, 14 divided by 2 is 7. Notice, even to even to odd. This one needs absolute values. And then letter D. Letter D is a little bit different because the square root doesn't completely simplify. I'm going to have stuff left inside. So I'm going to take that 48 and break it apart using the factor tree. 48 is, let's do 4 times 12. Everybody, you're aware that with the factor tree, you can break it up however you want to. As long as you break it all the way up, you get the same answers. So 48, 4 times 12. 12 is 4 times 3. Now you've got two options here. You could break the 4s apart and take out 2 sets of 2. Or you can say, okay, we've got a set of 4s right here and just take those out right now. I'm actually going to use a different color here for the things I'm taking out of the root. So 4s on the outside. Inside my square root, I still have a 3 left over. For the A's, a to the 8th, that's 2, 4, 6, 8, 4 sets of A's, none left over. So a to the 4th power. B to the 7th power. How many sets of B's can I take out? 3, right? 2, 4, 6. So B to the 3rd power. But there's 1 B left over, right? If I wrote out 7 B's, I'd have 2, 4, 6, 1 B left over. That leftover one needs to stay inside my square root. Now to check for absolute values. A goes from to the 8th power to the 4th power. Those are both even, no absolute values. B, if I put a negative into B, this whole thing becomes imaginary, doesn't it? Does the same thing happen down here? If I put a negative in, does my square root still become imaginary? Right, there's a negative in there. So these already match. I don't need absolute values anywhere. We're set. Any negatives put into A disappear. Any negatives put into B make it imaginary. We're good. And again, you guys, I know it's kind of warm in here, but do keep your masks all the way up. They just sent out, the Center for Disease Control sent out another little announcement saying, again, masks worn at all times indoors, keep them up. I know it's not anyone's favorite thing, but that's what we got to do. So we're actually going to skip letter E for right now. Let's do a couple examples. No, wait, let's do F first, then we'll do an example together, or have you guys do a homework example. So letter F has a number, -2, and a variable B on the outside already. They're just going to be out there multiplied by whatever you take out. So here, -2B, that's going to stay. Let's use a different color. I'm going to write that -2B out in front. Then I'm going to do the square root the same way we've been doing for everything else. Take the 60, break it apart. Give me some numbers. What multiplies to make 60? Yeah, 15 and 4, 6 and 10. I heard both of those. Let's do the 6 and 10. 6 is, what breaks up into 6? Or what multiplies to make 6? Yep, 3 and 2 or 2 and 3. The 10 would be 5 and 2. I'm going to go ahead and write it as 2 and 5 so that we have the 2's next to each other. Try to make it easy to see that we have a set of 2's right here that's going to come out. It's going to be multiplied. Anything out in front of that square root is going to get multiplied together. So -2B times 2. Left inside the square root, I still have a 3 and a 5. They're multiplied together also. Is everybody clear that everything is just multiplied right here? There's no adding or subtracting so far. A to the 4. I have 2 sets of A's. Those can come out. So A squared. The B, I only have 1 B. It doesn't come out. It stays inside. So now -2 times 2. -4BA squared. Really, we'd normally flip that around and make it -4A squared B. The important thing, though, is to multiply that -2 and 2 together. Those get multiplied together. And then on the inside, 3 times 5 is 15. Square root of 15b. There's my answer. So the only new thing here was that whatever got pulled out of the square root got multiplied by the negative 2b that was already out there. Are we okay there? All right. Why don't you guys try number 16 on the homework? It's going to be real similar to that one that we just did. Again, you're in groups, help each other out, check with each other. So the easy way to do a factor was you said doing 16, so that's 24. To go ahead and grab a factor, the easy way of doing a factor is just to divide by a number, like find a number that goes in. So you do 24, try to divide by 2, divide by 4, divide by whatever. So once you find one that works, yeah, you do. So you do 24, divide by 2, you get 12. So the factor trees then are 2 times 12. Those are the 2 numbers that multiply 2 numbers and multiply the next one. And then keep going. So the 2 is as small as it's going to get. 12, break that one apart. 6. So you're just looking for pairs of numbers. So we've got a pair of 2s here. I will circle those. And then those go on the outside. So you write 1, 2 on the outside. There's already one there. Take 1 for this one. Times 2. The 2 and the 3 that don't have to stay inside the square root. Give yourself a square root of 2 and 3 inside. And then you're going to do the same thing we've been doing so far with these. And the 4, how many sets of 2? Because you broke them apart. This 12 is made up of the 2 and the 6. The 6 is made up of the 2 and the 3. You only use the ones that are on the ends of each of those. That makes sense. And then do the same thing with the variables and doing so on. So figure out how many A's and then check with how many A's have on the row. Yeah. Oh, not right. The B is right here. We don't take the square root of that exponent. So the reason a to the 4th becomes a squared is because you have 4, 1 set, 2 sets. Right. B to the 9th, you've got 9 of them. So 2, 4, 6, 8. That's B to the 4 with 1 left over that stays inside of it. Again, that's why I'm doing this example with everything. A lot of people want to do that. All right. Yeah. No, so you see how many sets of these you pick up. So you do okay, 2, 4, 6, 8. You pick up 4 sets of these, and then there's 1 day left over. So that 1 is inside, you got to go 4 out. Right. So we're doing another example, even ones that aren't necessarily required. Like I want you to do here. You got 4 3s, that's it. 1, 2, 2, 3. It'd be 3 or 4. You can do it that way. So you're gonna have to 2, 3, 3 squared. So you go how would it be a 9 on the outside. Keep going. You want to go up there? Do you need the convention one?
Must have gone. Couple of houses.
All right, let's go over that 16 real fast. So let's see. Nick, did you get an answer for 16? And I have to get used to everybody's new seats they were.
4 is the second power, the fourth power, square root of 6.
So real quick, the way we get this, we had a set of 2's, right, that came out of the 24. That got multiplied by the 2 that was already out there. So 4. We had 2 sets of a's, a squared. We had 4 sets of b's, b to the 4th. But left inside the square root, we had a 2 and a 3. And 1 extra b. So 4a squared, b to the 4th, square root of 6b. All right, back to the notes. Let's go ahead and skip G. It's very similar. E and G are almost identical to the one we just did. So we're going to skip on down here to letter H. So for letter H, this one has a negative on the outside. That's really the main difference here, and then we've got a couple other things that get multiplied together. So I'm going to break apart. Let's start by just writing the things that are on the outside. The negative 5ab, put that on the outside. It's going to stay there. Take the 54 and start breaking that apart with a factor tree. So 54 we could say is, you could do this a couple different ways. I'm going to do 2 and 27. And again, if you're not sure with these factor trees, grab a calculator. 54 divided by 2 gets you the 27. If you're not sure what 27 is, try, okay, 2 doesn't go into it, but if I try 3, 27 divided by 3 is 9. And then 9 would be 3 times 3. So I have 1, 2, 3 3s. I'm going to pull out a pair of 3s here. Actually, let's use a different color. Pair of 3s would go on the outside. Then left inside the square root, leave a little space for your variables here. Left inside the square root, I would have the 2 and the 3 here. So 2 times 3. A to the 5th power. A to the 5th power. That's 2, 4. I can get 2 sets of a's. So a squared. But I have an a left over. And then b, we've got b to the 7th. B to the 7th power, 2, 4, 6, 3 b's. So 3 sets of b's, 1 b left over. So I'm done now. I just have to clean it up. Go through 5, negative 5 times 3 would be negative 15. A times a squared would be a cubed. B times b cubed would be b to the 4th. And then inside my square root, 2 times 3 is 6, ab. And here, no absolute values anywhere because notice how neither of my starting ones were even. Does that make sense to everybody? They're both odd to begin with. So any negatives I put in, it's going to make it imaginary. Any negatives I put in here are still going to make it imaginary. So that is my answer. The last thing we need to go over is how to do that with cube roots. So these last few examples down here, J or I, J, K, L, we'll probably do 2 out or 3 out of the 4 here. The cube root of 64. Remember, we already found, we listed those out. 64 is 4 times 4 times 4. So this would just be a 4. Okay, before we were dividing the exponent by 2. Anyone want to guess? If I'm looking for sets of 3 here, I could write out 12 x's and circle them. Is there a faster way? Divide by 3. Does that make sense to everybody? Cube roots, divide the exponents by 3. So this would be x to the 4th. And y to the 6th divided by 3, y squared. In many ways, cube roots are easier than square roots. You never have to worry about absolute values with cube roots. Does it make sense? Yeah. So these are good. Only some of them work out that nicely. We're going to have others where you'll have stuff left inside. But it's exactly like what we were doing before. You're just, again, looking for sets of 3. So for letter J here, letter J, the cube root of negative 24, x to the 3rd, y to the 4th. The negative, just bring it out. Anytime you have a negative inside a cube root, put it on the outside. Your answer is going to be negative. Cube roots have no problems with negatives. The 24, we're going to break apart and look for sets of 3. So 24 is 2 times 12, which 12 would be 2 times 6, which would be 2 times 3. So we do have a set of 3 2s. I'm going to take all those out. That 2 goes on the outside. Left on the inside, we'd have 1 3 left over. Okay, right now, before I forget, I'm going to put the cube root on here. That is so easy to forget, and that's going to be a point off because a square root is very different than a cube root. We're starting with a cube root, it needs to stay a cube root. So don't forget, I would put it right away. Always double check. Am I dealing with square roots or cube roots? This one was cube roots. There we go. Now, I'm going to do the same thing with the variables. X to the 3rd, that's 3 x's. That's one set of x's. That comes out. Y to the 4th, I can get one set of y's, but there's going to be 1 left over. So my final answer here, negative 2x, y, cube root of 3y. So again, a little harder than the other one because you've got those leftover pieces, but it's mostly working the same way. Let's skip letter K. Letter L. Letter L is exactly the same thing, but now we have stuff on the outside that we've got to multiply by when we're done. So I'm going to put that stuff on the outside. 5x squared. Just set it off to the side here. 5x squared. Take the 40, break it apart. Four times 10, 2 and 2, 2 and 5. So I have 3 2s right there. 2 times 2 times 2. And let's take the negative out along with those. So I'm going to put a negative 2 on the outside here. But there's still going to be a 5 left inside. Go through the variables. X to the 3rd. I have one set of 3 x's. And I almost forgot it again. You'll see how easy it is to forget. This is a cube root. Don't forget to put the cube root part on there. Y to the 7th would be 3, 6. I can get 2 sets of y's. So y squared, 1 y left inside. How many sets of 3 z's can I get out of 11? 3. So z to the 3rd. And then how many are left over? 2. Z squared. Last thing to do is clean it up. 5 times -2 is -10. X squared times X is X cubed. Y squared. Z cubed. Cube root of 5YZ squared. That is by far the hardest one that you're going to see today on the homework. There's maybe like 1 or 2 like that. Most of them are going to be dramatically easier, like the other ones we did before. Any questions on that? You got about 6 minutes here to get some more of the homework done. We've trimmed it down a little bit. You're doing numbers 1 through 9 all. Those should be real nice and quick. Some of you are probably already done with those. And then 11 through 33, just the odds. Okay. Just a quick reminder. I know we had 2 weeks off. You must show your work. That's what you're getting credit for here. You must show your work. If you have questions, ask. I'll be here during lunch and after school as well for a little while. This is the foundation, what we're building on for the rest of the unit. This whole unit's on roots. So we go from here. Today, we're just simplifying. Tomorrow, or for you guys Thursday, we'll be multiplying and dividing. Then we'll be adding and subtracting. We'll work our way all the way up. Other than that, it's good to see you all. Welcome back. Let me know if you have questions. But again, take a few minutes, get as much of that homework done as you can.